A researcher is interested in estimating the population mean mu that Perth residents had spent via online shopping in December 2020. A random sample of size n gave a sample mean of 400, a sample standard deviation s, and a 95% confidence interval of width 200. State the 95% confidence interval obtained. So what do we know about this confidence interval? We know that the width of the confidence interval is 200 and the middle will be 400. So in other words, with 400 in the middle and a width of 200, that means 100 either side. So it's going to go from 300 to 500. So 300, 500. Calculate the standard deviation of the sample mean correct to 1 cent. So it's a 95% confidence interval, so we need the value for Z95. So I can find that from my e-activity, and I've got z-score for confidence interval here, and it's actually set to 95 at the moment. So I can see that's 1.95996. So think about how the interval is actually calculated. And we know from the 400, we go up and down by what's known as the standard error. So 1.95996 times s over root n is equal to 100. So that's how we calculate the standard error, and the standard error is 100. And don't forget that this bit here, the s over root n, is basically s of x bar, which is what we're trying to find, the standard deviation of the sample mean. So it's just basically going to be 100 divided by 1.95996. So 100 divided by 1.95996 is 5102. Okay. In terms of n, what sample size would yield a 95% confidence interval of width 50? So if we're talking of width 50, then we're talking up or down by 25. So let's say that the sample size here is, let's call it m. Then it follows that s over root m would be equal to 25 over 1.95996. Or if you like, that's equal to 1/4 of s over root n. So s over root m is equal to 1/4 of s over root n. Well, the s's all cancel here. And then we could get root n is equal to, let's take the 4 up with it as well. So 4 root n is equal to root m. And squaring both sides gives me that m is equal to 16n. What is the probability that another sample of size 2n would produce a sample mean that differs from mu by more than 50? Well, we know that x bar is a normal with a mean mu and a variance which is basically s squared over 2n. That's for this new sample because remember we've got sample size 2n. That means that x bar is a normal mu. Now we know that s over root n was 51.02. So this is going to be 51.02 squared because it's s squared over n, and 51.02 was s over root n, divided by 2. Now what we're after is the probability that this differs by more than $50, which we know is 1 take away the probability that it's within $50. So in other words, x bar minus mu would be between negative 50 and 50. Now, we know that x bar minus mu over sigma is z. So that's 1 take away the probability of z being between. So what we need to do is 50 divided by 51.02 over root 2. And that gives me 1.3859. So negative 1.3859. And on this side, we'll have 1.3859. And that calculation will give us the probability that we want. So let's do the probability first. So normal CDF from negative 1.3859 through to 1.3859. Now it's standard normal, so leave the 1 and 0, and we get this, and it's going to be 1 take away my last answer, which gives me 0.166. Now we've got 4 different intervals, A, B, C, and D, some details just here, are obtained for the mean amount spent via online shopping by Perth residents in December 2020. Which of the confidence intervals A, B, C, or D contains mu, the population mean expenditure for online shopping in December 2020, and justify your answer? Well, mu is unknown. There's no guarantee that any confidence interval will contain the mean. For each of the following, state the confidence interval that has the smaller width and justify your answers. So we're judging between A and B to start with. Now, they have the same sample size, the same standard deviation, but the confidence level is less for A, and that means it will be narrower. Greater confidence interval, a greater confidence means a wider interval. So that is going to be A, and that's lower confidence. And then finally, we want to compare between C and D. Now, it would be easy to jump here and go for C because of the 2n, but note the smaller standard deviation for D. So we're actually going to have to calculate here. So if we think about C, the standard deviation for this sample would be S over root 2n, which of course is S over root n times root 2, just splitting the third on the bottom there. So if I do 1 divided by root 2, that gives me 0.707. So this one is 0.707 S over root n. Now if I do the same sort of calculation for D, so for this one, that is going to be 0.8 S over root n, which is 0.8 S over root n. And so we can see that this one is smaller just because 0.707 is less than 0.8. So the answer is C.